Good afternoon everyone, welcome to the channel. Today I want to talk about internal cluster validation. I also previously made a couple of videos on this topic, but today I want to perform some new metrics using a very good module that's available in Python. Okay, so let's get started. Let's import the required libraries. So I want to use ClustersFeatures module from ClustersFeatures import cluster characteristics. Let's check the module version. ClustersFeatures module version. ClusterFeatures dot version. Also we need pandas from sklearn dot datasets. Import make classification from sklearn dot cluster. Import k-means. So module version is 1.0.3. Let's create our dataset. Okay, features. We don't need the labels. We will generate labels from k-means later. We only want to get the features from here. Let's check the shape. Features dot shape. So 250. Okay, let's mention in samples here. So 250 samples and 4 features. This is how the shape is showing. Okay, now let's perform k-means considering 2 clusters. At first, create a data frame using the features. K-means 1 and clusters will be 2. Random state 0 init auto. Let's fit our data. Sorry, not this one, tf1, and we get the labels. From here, after getting the labels, we want to add a new column to our data frame. Labels 1. Then print. Check the shape of our data frame. Labels on unique. Then so we will use this function that belongs in this module. So cluster characteristics For this function to work, we need to provide the data frame, entire data frame, and also we have to mention which one is the class, or which column is the class of this data frame. Okay, so label target labels 1. Let's check first few samples. What happened? Oh, sorry. Okay, too many mistakes. Okay, so this is our classes. So we can see from this line, since we consider 2 clusters, there are 2 labels, 0 and 1. Okay, now we have to repeat the same process for 3 clusters. So perform considering 3 clusters. So we have already copied, so we have to change a few things. Sorry, not here. Give it a new name. It will be 2. This will be 3. This will be 2, 2, 2, 2, then 2, 2, 2, 2, 2. This will be 2. This will be 2. I hope everything is okay. Okay. So you can see 250 samples, 4 features. Last column is obviously the classes. In total there are 5 columns and 0, 1, 2. So for 3 clusters you have 3 different labels, 0, 1, 2. Now the easy part. Calculate ball hole index. So print ball hole index for 2 clusters round CC1, I think. Score index, then ball hole. Okay. Five. Okay, and now for 3 clusters we have to just call 3. Okay, so that's how easily using this module we can calculate ball hole index by calling this method. Lower value ball hole index means better clustering. So in this case 1.19 is lower than 2.07. So this is better clustering compared to this one. Now let's calculate another matrix. So now we want to calculate Banfeld. Raftery index. Let's copy and change. Control C. So this will be Banfeld-Raftery. To instead of in Paul Hall, we have to use Banfeld-Raftery. And for 3 clusters, we have to change it to CC2. I think it's okay. Okay. Let's copy, Control C, Control V. So Banfeld-Raftery index means vertical size. So in our case, this is lower compared to this one. So both these metrics are showing 3 clusters for our data set is better than 2 clusters. Let's calculate another one. So calculate Ray-Turi index. Calculate Ray-Turi index. Let's copy and change. Control C. Okay, this way. So Banfield, not Banfield. Banfield. Ray-Turi index. So we have to change Banfeld-Raftery to Ray-Turi. Okay. So let's copy and do this for 3 clusters as well. This will be 3, 2. So Control C of Ray-Turi index means better clustering. So 0.2 on for 3 and 0.3 on for 2. So all three index are agreeing till now that 3 is better than 2. Let's check the next one. Calculate Xie-Beni index. Copy and change. So this will be Xie-Beni index, and you have to change to Xie-Beni. 3 clusters. This will be 2. Okay. Control C. Lower value of Xie-Beni index means better clustering. So again 3 is lower than 2. Let's calculate another one. Calculate C index. Again copy and change. C index C. Okay. Control C, Control V. This will be 3. This will be 2. So 0.10 and 0.15. This one also is same like the previous one. Lower value of C index means better clustering. So 3 is lower. Let's calculate next one. Calculate Mclain-Rao index. You can copy and change. Ctrl C, Ctrl V. Mclain-Rao. No A, sorry. So score in index Mclain-Rao. Ctrl C, Ctrl V. 3. Okay, this one is also like all the previous ones. So lower value of Mclain-Rao index means better clustering. So all of these, the lower the value for all these, how many? 1, 2, 3, 4, 5. So we have calculated 1, 2, so we have ball hole, and Banfeld-Raftery, Ray-Turi, Xie-Beni, C, and Mclain-Rao. So 6. So all these 6 metrics, for all these 6 metrics, the lower the value of the index, the better is the clustering. Now let's calculate some different ones. Calculate Wemmert-Gancarski index. Gancarski Wemmert. So we have to use Wemmert-Gancarski. Okay, so this will be 3, this will be 2. Okay, this is different compared to the previous 6 ones. So in this case, higher value of Wemmert-Gancarski index means better clustering. So in this case, we have this one higher than this one. So 3 is better than 2. Let's calculate the final one for this video. Calculate PBM index. Just copy, Ctrl C. So we have PBM index, PBM. This will be 3, 2. This is same as Wemmert-Gancarski. So higher value of PBM index means better clustering. So we have calculated 8 metrics in this video, and we created a dataset using the make classification function from scalar datasets. 250 samples, 4 features. Then we performed k-means considering 2 clusters and 3 clusters. Then we calculated these 8 index, namely ball hole, Banfeld-Raftery, Ray-Turi, Xie-Beni, C, Mclain-Rao, Wemmert-Gancarski, and finally PBS index. So last 2 higher value is good for last 2, Wemmert-Gancarski and PBM. Lower value is good for the first 6. And this is a very powerful package. We basically did nothing, just call the method and calculated the index. So make sure to check this version. Okay, that's the end of this video. Thanks for watching.